Hello everyone, welcome to my general chemistry mini lecture. Today our topic will be stoichiometry. It is a mole calculation based on balanced chemical equations. Usually the given condition for stoichiometry is the amount of one chemical in the equation, and that chemical could be reactant, could be product. And the unit of the given amount could be molecules number, could be moles, could be mass in grams. And today I will show you two different ways to solve stoichiometry. The first way is using the mole ratio as conversion factor. The second way is use a proportion. I will give you 5 examples today. First example is shown here. The question is that how many moles of oxygen molecule are needed to completely react with 6.28 moles of phosphorus according to the following reaction. This is a balanced reaction. And actually there's another question. How many moles of diphosphorus pentoxide will be produced? Okay, this is actually 2 questions. And since the given amount of the phosphorus is in moles, so we can use the ratio of a coefficient as mole ratio. Okay, this number in front of those chemicals called coefficient. And the coefficient, it is the ratio of molecules, but it's also ratio of moles. So we can always write the moles as a unit for this coefficient. So now the ratio of these chemicals, reactant, product, is actually the mole ratio now of the coefficient. So if we need to calculate how many moles of oxygen and we have this phosphorus as a given, we can use the number of moles of the phosphorus, which is given, convert to the moles of oxygen, which is the question. And so this is a given condition. And this is called a mole ratio. You can see the mole ratio is the coefficient ratio of the oxygen to the phosphorus. This 5 is this 5. The coefficient is this 5. And this 4 is this 4. Is coefficient of the phosphorus. So in this way, you use this mole ratio, you can convert the phosphorus moles to the oxygen moles. And you cancel the moles of phosphorus here. So in your calculator, just use 6.28 times 5 divided by 4. So you get 7.85 moles of oxygen molecule. For the other reaction, for the other question, we need to calculate the number of moles of diphosphorus pentoxide. So we can use the same given condition, that's phosphorus, 6.28 mole, and then multiply with the mole ratio. This time, the mole ratio of the diphosphorus pentoxide over phosphorus is 2 to 4. That's 2 to 4. 2 to 4. Okay, so that's the coefficient ratio. And then basically in your calculator is 6.28 times 2 divided by 4. And then 3.14 is the answer. 3.14 moles of the diphosphorus pentoxide will be produced. Okay, this is the first way using the mole ratio as conversion factor. The mole ratio is the coefficient ratio in the balanced equation. The other way to solve this stoichiometry is the proportion. I will show you now. So using the proportion, same question. Okay, exactly same question. And the same coefficient, right? So same mole ratio. So we can write this in moles of those coefficient. Now we have the given condition is 6.28 mole of the phosphorus. And then question is how many moles of the oxygen molecule needed and how many moles of the product formed. So that's the product, how many moles of the product will be formed. So we can use X, Y, if you have other question Z, so that's the symbol of the unknown. Okay, so let's say we will need X moles of oxygen molecule and produce Y mole of the product, diphosphorus pentoxide. Now, we have all the unit, look at the unit of this given, this mole, the question also mole, questions also mole. So this kind of question will be very simple. We just write the number of moles, which is actually coefficient of the corresponding chemical. So that's phosphorus 4, that's oxygen 5 here, that's the product 2 here. And then this will be in proportion. So we can write in proportional way. Okay, so now we can just solve the X and Y. So first, let's solve the X. X will be equals 6.28 times 5 divided by 4. So X will give 7.85 mole. Okay, that's for oxygen. That solved the first question. And then solve the other question, Y. So Y equals also the cross multiplication of these two divided by 4. So Y equals 2 times 6.28 divided by 4. So give you 3.14 moles of the product. So this is the way of proportion. Exactly the same question. Okay, so yeah, I will say you can choose any method to solve the stoichiometry. Both are okay, and both methods give you exactly same answer. So they are all correct. So it depends which way you like. You can choose the way you like to solve the stoichiometry. Okay, now let's show you another example here. Okay, let's talk about another example. This is a question: how many grams of water will be produced from 3.50 moles of methane? This is the balanced equation. And you can see the coefficient of the methane is 1, oxygen is 2, carbon dioxide is 1, and water is 2. So this also gives you the mole ratio of all these 4 chemicals. For the question, they ask you the mass of water. They give you the moles of the methane. So we can first, we need to calculate the molar mass of the water, because we later we'll need this molar mass to calculate the mass. Molar mass of water is 2 times molar mass of hydrogen, 2 hydrogen, plus molar mass of 1 oxygen. So you can find this molar mass from the periodic table. Usually it's the number under the symbol. It's called atomic mass. And so you can calculate the molar mass of water is 18.02 grams per mole. Now we have a given condition, 3.5 mole methane. We can convert that mole to the number of mole of water. So we need to use this mole ratio, 2 to 1. 2 mole of water over 1 mole of methane is the mole ratio. So cancel the mole of methane, we can get the number of mole of water. When you have the moles, we can calculate the mass. Mass equals moles multiplied with the molar mass. So the moles is 7 and molar mass of water is 18. We just calculate that. So you get 126.1 grams of water will be produced. Okay, you can also use just the one setup. So the given condition, 3.5 mole of methane, multiply with the mole ratio, water to methane, 2 to 1. And this step, you get the mole of water, cancel the mole of methane. Then second step, multiply with the molar mass of water with the number of moles of water, give you the mass of water. That's 126 grams of water produced. Okay, this is the way using mole ratio. Now, we can use this proportion. How many grams of water will be produced from the 3.5 mole of methane? Exactly same question, same balanced chemical equation. So same mole ratio. Now, using proportion, we need to identify the given condition 3.5 mole methane, write that here under this methane. You have to write it exactly under this methane. Okay, that's very important. And then identify the question, how many grams of water? Water is here. And since this is a mole, you will need to convert this 2 mole to mass, 2 moles of water. So question is grams. So we need to convert this 2 mole water in this balanced equation, 2 times 18. We just calculate the molar mass of water in last slides, right? So 2 times 18.02, the molar mass of water. So 36.04 grams is the mass of the 2 mole of water. So now we can write this 36.04 grams over this x. This is a question. And this is 1 mole because the given condition is mole. So you still use 1 mole. That's 1 here, coefficient. Then this is in proportion. Solve the x. X equals 3.50 times 36.04 divided by 1. So that's 126 grams of water will be produced. Okay, so this is the second question, second examples. Okay, now third example. Okay, another example shown here is how many molecules of ammonia can be produced from 276 grams of magnesium nitride according to the following equation. So this is the balanced chemical reaction. Okay, and since this given condition is mass of the magnesium nitrate, we actually need to convert this mass to mole first before we can use the mole ratio, the first method. Okay, and the question asks you the molecules of ammonia, so we need to calculate moles of this ammonia first and then convert to molecules. So again, we have this balanced equation, we have this coefficient, that is the mole ratio. If you don't see any number, that's 1. And we need to calculate the molar mass of this magnesium nitride first before we convert that mass to mole. So molar mass calculation, there are 3 magnesium and 2 nitrogen in the formula. So we need to use 3 times molar mass of magnesium. The molar mass of the element can be found in the periodic table. That's the atomic mass under the symbol. And then you have plus 2 nitrogen, 2 times 14.01. So the molar mass of the magnesium nitride is 101.0 grams per mole. And then we can convert the 276 gram to mole. How to calculate the moles? Mass divided by molar mass, give you moles. We have a mass, 276 grams as a given condition, divided by molar mass. We just calculate that, and we can find the 2.73 moles of magnesium nitride. And then we have the number of moles of the magnesium nitride. We can convert that mole to ammonia, so by the mole ratio. So that's 2 to 1 of ammonia to magnesium nitride, 2 to 1. So that's the ratio of coefficient of these two chemical. And then we can calculate the number of moles of ammonia, 5.46. And then last step, when we have the moles of the ammonia, we can calculate the number of molecules by moles times Avogadro's number. So that's 5.46 times Avogadro's number, 6.022 times 10 to the power of 23rd, and that gives you the 3.29 times 10 to the power of 24th. Okay, so that is the answer, and you can also set up in one step. So we can convert the mass to mole, mass over molar mass for the magnesium nitride, and then convert to moles of ammonia by this mole ratio of the ammonia to the magnesium nitride. And then last step, when we have moles of ammonia multiply with Avogadro's number, we can calculate the molecules number. okay, of the ammonia. So give you the same answer, of course. This is just a one-step setup. Now next I will show you the other method using proportion, the way of proportion here. So exactly same question, same given condition. So we can write this same thing. So the ratio, mole ratio, that's actually the coefficient ratio here. And then we write the mass of this magnesium nitride. This is a given under the magnesium nitride here, 276 grams. So when you see the unit is grams, in the proportion here must be in grams. Okay, so keep that in mind. So what's the question? How many molecules of ammonia? Ammonia, how many molecules? We can say X molecules. We don't know, right? So we need to calculate that. Now you also notice the unit is molecules. Okay, so why we have to pay attention to here? Because this unit is mole. So if this unit is different with mole, you need to convert the mole to the same unit. For example, 1 mole of ammonium nitride, we need to convert that to grams. 1 mole of the magnesium nitride equals the molar mass, right? So 1 mole times the molar mass is the molar mass of magnesium nitride. We just calculate that in last slide, right? So that's 101.0 grams. Basically, it's 1 times molar mass. And for the other one, ammonia, 2 moles times Avogadro's number, we can have 1.204 times 10 to the power of 24th. So that is the number of molecules. Now we can do the proportion. We copy this mass to here. So make sure they have the same unit. Copy the molecules number to here, same unit. So now in the proportion, we can solve the X. So we can cancel the molecules, the unit, then in your solution, the X will be just this 2 number cross multiplication divided by this number. That's it. So 276 times 1.204 times 10 to the power of 24th divided by 101.0. So give you 3.29 times 10 to the power of 24th. Same answer with the other method. Okay, so this is the example calculating the number of molecules. Let's look at another example. Now, the question is how many grams of sulfuric acid is needed to produce 125.4 grams of aluminum sulfate? So now this question also give you the mass of the product as a given condition. Ask you calculate the mass of one of the reactant, sulfuric acid. So first I'll show you the way using mole ratio again. So again, we can write this, the mole ratio, okay, based on the coefficient ratio. That's all mole ratio. Again, if we don't see coefficient, it's 1. Then, since we have a mass of the aluminum sulfate, we need to convert this to mole. So we need a molar mass of the aluminum sulfate. We also need a molar mass of this sulfuric acid because we eventually need to calculate the mass. So we need to calculate molar mass of this sulfuric acid, 2 hydrogen plus 1 sulfur plus 4 oxygen. So that's 98.09 grams per mole. Aluminum sulfate molar mass is 2 aluminum plus 3 sulfur plus 12 oxygen, 342.2 grams. Okay, so you need to multiply the subscript with the subscript in the parentheses when you calculate the number of atoms. Now we convert the mass of aluminum sulfate to mole, mass over molar mass, that's given, divided by molar mass, we just calculate, we get 0.3665 mole of aluminum sulfate. Then convert the moles of aluminum sulfate to moles of sulfuric acid by this mole ratio. You see, we always put this given moles to the denominator to cancel the given moles of this aluminum sulfate. We cancel that, we can calculate the number of moles of this question sulfuric acid. 3 to 1 is the coefficient, 3 to 1. That's a mole ratio. And we get 1.099 moles of sulfuric acid. Last, we need to calculate the mass of the sulfuric acid. So moles times molar mass. Moles, we just calculate, times molar mass, we just calculate. So of the sulfuric acid, that's mass of sulfuric acid calculated is 107.8 grams sulfuric acid needed. We can also set up in one step. So mass of the aluminum sulfate divided by molar mass of the aluminum sulfate give you the moles of the aluminum sulfate. Multiply with the mole ratio of the sulfuric acid to the aluminum sulfate, 3:1, and can calculate the number of moles of sulfuric acid. Then multiply with the molar mass of the sulfuric acid. We can calculate the same number, 107.8 grams of the sulfuric acid needed. Okay, this is the way using mole ratio. The other way using proportion. So same question. Okay, so we can write the ratio in moles, the coefficient ratio, and then we have the mass of the aluminum sulfate given. So you write that under this chemical here, 125.4 grams. So this is a mole. So we need to convert the mole to mass. This is 1 times the molar mass of the aluminum sulfate will be here. Okay. So what's the question? How many grams of sulfuric acid? So X grams. We don't know how many grams. So again, this is mole, and we need to calculate grams. That's grams. So both we need to convert the mole to mass. So here, 3 times molar mass of sulfuric acid. We just calculated this in previous slides. So 3 times 98.09 equals 294.3 grams. And then for this aluminum sulfate, just 1 mole. So basically it's the same as the molar mass. So you can say 1 times the molar mass is the same thing. Now move this to mass over here. And that is in proportion. And then you can solve the X. Cross multiplication divided by this number, and then you get the same answer with the previous slides, 107.8 grams. Seems like the proportion way is a little bit straightforward, right? More straightforward. So it's up to you which way to use. Okay, both give you the same answer. Okay, here's the last example. I'm going to show you. Find the mass of the iron 3 oxide. This is actually iron rust that is required to completely react with 27 grams of hydrogen chloride, or you can say hydrochloric acid. And how many grams of the iron 3 chloride will be produced? So this question actually included 2 questions. Okay, so this is a balanced chemical equation here. So the coefficient ratio again is the mole ratio. So we can write that down. You don't have to always write this down. Okay, if you understand it's the mole ratio. So I just want to write down to show you the mole ratio. And then since we have all the mass given and the question asks you calculate the mass, so we need a molar mass of these 3 chemicals. The first one is the iron 3 oxide, 2 iron plus 3 oxygen, 159.7. Molar mass of hydrogen chloride, first hydrogen, second chlorine, so it's all 1, so that's 36.46. The molar mass of the iron 3 chloride is 1 iron and 3 chlorine, so that's 162.2. Now you need to convert the mass of the hydrogen chloride, mass over molar mass, that give you moles, and then convert that to moles of iron 3 oxide using this mole ratio of the iron 3 oxide to the hydrogen chloride, 1:6. It's here 1:6, 1/6. And then after this calculation, it give you the moles of the iron 3 oxide. Then multiply with the molar mass of the iron 3 oxide. You can get the mass of this iron 3 oxide. I didn't show the stepwise, just to show in one step. And the other question, how many grams of the iron 3 chloride will be produced? We still have the same condition, given condition, 27 grams of the hydrogen chloride over molar mass, that's the same, but now this mole ratio is different because now we need to calculate iron 3 chloride. So mole ratio will be the 2 to 6. 2 to 6. And then multiply the molar mass of this iron 3 chloride. And then you get the answer. So basically in your calculator, you have 27 times 2 times 162.2 divided by 36.46 and then divided by 6. Okay, so answer is 40 grams of the iron 3 chloride will be produced. Okay, I will show you the other way, use a proportion. Okay, so this is the way using proportion, and this is exactly same question. Okay, so we can write the mole ratio. And again, I just want to remind you, if you understand the ratio of the coefficient, it is a mole ratio. You don't have to always write another chemical equation like this. Okay, for me, I just easier for me to show you how to do it. Okay, now the given condition is 27 grams of the hydrochloric acid here. You write down this mass under this hydrochloric acid or hydrogen chloride. And then question is mass of iron 3 oxide. We want to find a mass of the iron 3 oxide, X grams. We don't know how many grams now. And also another question, how many grams of the iron 3 chloride? And under this, you write a Y grams. Those are both unknown. Since this is all grams, so we need to convert the unit here, mole to mass. So 1 mole, of course, just 1 molar mass of this iron 3 oxide. We just calculate the molar mass last slides. For this hydrogen chloride, 6 times molar mass of hydrogen chloride give you 218.8 grams. And then this is 2 times molar mass of the iron 3 chloride give you 324.4 grams. Then we can set up the proportion. Write the mass to here, the mass here, the mass here, and that in proportion. We have 2 unknown. Okay, so we need to solve one by one. First, solve the x. X equals cross multiplication divided by this number, so that give you 19.7 grams. That's iron 3 oxide. X is iron 3 oxide. To solve y, another proportion, y equals 27, cross multiply with the 324.4 and then divided by 218.8. Give you 40 grams of the iron 3 chloride produced. Okay, so this is the way I basically showed you 2 different ways to solve the stoichiometry. Okay, please let me know if you have any questions about it, and good luck.